afternoon, all of you. I am talking on spatial analysis, mainly on raster analysis. So if you see that overall GIS, heart of GIS, what you do some analysis and produce some outputs, do the modeling and then get the output, desired outputs, visualization. All this thing we do it through analysis. So we do it in two modes. One is a raster model, another is a vector model. If you see the softwares also, they operate in both the things. One is in vector mode, another is a raster mode. So there are some specific type of applications we can do in a raster, and some specific type of application or analysis we can do in a vector. If you wanted to maintain the topology, then vector is the best you can represent. And then if you wanted to do related to watershed analysis and then file progression model, etc., and then raster is the best option. If you wanted to do continuous type of features that you wanted to represent and then do the analysis, so then the raster is the best. And then some softwares work only on the raster, some softwares work only on the vector. So that's why it is required that you should understand different type of analysis, how it is done in both the cases. So we had a talk on vector analysis by Dr. Samir. So I will be talking on a raster analysis. You might have done when you are doing a school education also, then different type of operations you do, mathematical operations like arithmetic operations like plus, minus, multiplication, division, etc., relational operation, less than, greater than, equal to, and logical operations, and or, exclusive or, and not. And then another thing is conditional operations like if-then conditions. These if-then conditions are applied when you are doing some type of models. So these are all type of operations what are mentioned here. So these things you can also do it in a GIS. So like if you have two types of layers, so you can combine together and produce a output and combination of both the things. You can also subtract some of the layers and get the output from that. So and then logical operations, you can take some input from one map, and then if you take some input from other map, so like that the third map can be produced taking these operations, logical operations. Even if then condition also, if the 10 type of feature and land use classes are there, then if you wanted to take only one type of feature, like you wanted to take only forest area, or you wanted to take a land area where the slope is more than 60%. So like that you can use all these operations and apply for the geographical type of features in the spatial analysis. So let us see some of the examples so that you get a better understanding of these operations and then analysis. Suppose if there is a map, let us consider also all this analysis what I am explaining are raster analysis. So if you take two maps, if A and B, like if you take a satellite data, they are also represented by DN numbers. So if you take two maps, and if I combine two maps together, I can produce a map of C. So that's why suppose map C is equal to map A plus 10. So then you are producing another map, this adding 10 value to the map. So that means each pixel, suppose if there is a 5 here, so that is modified into a 15 here, because 10 is added to map A and this is map C. So like that each cell you reproduce with adding a 10 value to that cell. Okay, so then your complete map is produced here. So similarly you can also see that map C1 is equal to map A plus B. Here the important thing is when you talk about analysis, we do analysis and then whatever you add or subtract those things, it is referred to this particular area, particular pixel. So that's why if I say that A plus B means, so this particular value and this particular value. So that means those are geographically belongs to same area. And then once you georeference, so then these maps can talk to each other according to the same location. Suppose you combine together, the same location values are added together or subtracted together or multiplied or ratioed. So in this case it is basically adding. 5 and 4 is addition, and here 6 and you have 8 is 14. So like that your map is produced. So similarly you can also produce another map a minus b by a plus b multiplied by 100. If you remember that remote sensing digital image processing lectures, you might have been told about NDVI, normalized vegetation index. Suppose that is like infrared minus red divided by infrared plus red multiplied by 100. So this is similar to that. So then you get an output using those two maps. Here in this case, these two maps are added. So you yourself can work out and get the output for this. So the same thing it is. Suppose when you do that, this is the output result for that map C2. And then another thing is relational thing. Suppose if you say map output is, this is the output, is equal to map A greater than map B. Suppose you say whatever the values you say in a map A, if they satisfy the condition of greater statement than the B, so then your output will have a true value, then it will have a value number 1 here. So that means wherever it is true, it will put 1. Wherever it is not true, it will put 0. In case of map A is equal to 5 here, and then map B is equal to 4. So that means map A value is greater than map B, justifying that that is correct, and then you are putting value 1 there. So suppose if it is 2 value, and then this is 8 value for the same location, this is B is greater than A, so it is not correct, so then it will put a false value. Your output will be a bit map. That means 1 and 0. If the statement is correct, it will put 1. If it is not correct, it will put 0. So another is relational and logical operations. So if you say that there are some of the maps are produced giving this condition. Suppose if you take map D is equal to map A, that is equal to forest, and map B is equal to less than 500. That means you apply here a Boolean operation combining two maps, map A plus map B, and then if it is that means both the statements has to be correct. Suppose if you take, it has to be map A is equal to F means forest here, 7 means 700, 600, and then 400. Here it is map A is equal to F, and then map B is equal to 7. So that means it should be less than 500. So that is not correct. So that is not taken. So that's why wherever the value is forest, suppose if this is the forest, and suppose this is forest here, and then this is less than 500. So both are conditions are say justifying. So then you will put a value here 1. So like that you produce a map. So see that you see. So these are all wrong. So though it is forest, but not just